Hi Year 12, this is the second video for the solutions to the 2022 Maths Extension 1 HSC exam. In this video we're going to look at questions 11 and 12. Question 11a. For the vectors u equals I minus j and v equals 2i plus j, evaluate each of the following. So nice easy question to start with. So we want u plus 3 lots of v and just collecting like components. We've got 1 plus 6, which is 7i, and then we've got minus 1 plus 3, so that's plus 2j. And then part 2, we want the dot product. Remember, we're going to multiply the coefficients of the like components together. So we're going to have 1 times 2 plus negative 1 times 1, which is 2, take away 1, which is 1. Question 11b. Find the exact value of this integral using the substitution u equals x squared plus 4. So we'll start with the substitution. U is equal to x squared plus 4. Let's find du dx. And it's equal to 2x. Now I'm wanting it to match this part here. So I'm actually going to make x dx the subject, like this. X dx is equal to du over 2. We also need to do these limits. So when x is equal to 0, u is equal to 4. When x is equal to 1, u is equal to 5. Okay, we're ready to substitute. Now one bit of advice I will give you is that when we're going from here into a substituted integral, we need to do the whole thing in one go. Don't have the situation where you've got half of it as x and half of it as u. So it's going to go between 4 and 5. This part here, remember, is going to be du over 2. And then this part on the bottom here is the square root of u. There's our substituted integral. All right, I'm just going to tidy it up a little bit so I can integrate it. 4, 5, it's u to the negative a half du is equal to half. Let's integrate u to the 1 over 2 divided by 1 over 2 in between 4 and 5. I can see that that cancels with that. And now let's substitute the 5 in. So that's going to give us the square root of 5. Take away, substitute the 4 in, square root of 4, which is 2. And that's our answer. 11c, find the coefficients of x squared and x cubed in this expansion. Now it's pretty easy to see that x squared is going to be the third term and x cubed is going to be the fourth. So I'm actually just going to expand this out. So it's going to be 1 plus 8c1 times negative x on 2 plus 8c2 times negative x on 2 squared plus 8c3 negative x on 2 cubed. Dot, dot, dot. So there's the term in x squared, and here's the term in x cubed. Let's just do them one by one. So x squared, first of all. We've got 8c2. We only want the coefficient, so it's negative a half squared, and then x cubed is going to be 8c3 negative a half cubed. All right, let's work this out using the calculator. So we've got 8c2, which is 28, negative 1 all squared is 1, and 2 squared is 4, quarter of 28 is 7. 8c3 is 56 times negative 1 cubed is negative 1, and 2 cubed is 8. 8 into 56 goes 7, so it's negative 7. Question 11d. The vectors u and v are perpendicular. What are the possible values of a? So remember, if perpendicular, it means the dot product is going to be equal to 0. So I'm going to go a times a minus 7 plus 2 times 4a minus 1 is going to be equal to 0, and we're going to get a quadratic. A squared minus 7a plus 8a minus 2 is equal to 0. A squared plus a minus 2 is equal to 0. Factorise. We want positive a, so I want the bigger one to be positive. Therefore, a is equal to 1 or negative 2. Question 11e. Express root 3 sine x minus 3 cos x in the form r sine x plus alpha. Now looking at this, and looking at this, and looking at this, I can immediately see that alpha is going to be negative. But let's start with r. So r is equal to the square root of root 3l squared, which is 3, plus negative 3l squared, which is 9, which is root 12. Let's tidy that up. We have 4 times 3, so that's 2 root 3. Now I'm going to work out tan of the absolute value of alpha. Okay, and then I'm going to put the negative in at the end. So that's going to be equal to 3 over root 3. Timesing top and bottom by root 3. I have got 3 root 3 over 3, which is root 3. So the absolute value of alpha will be equal to 60 degrees, which is pi on 3. So our answer is r is 2 root 3 sine x minus pi on 3. Question 11f. Solve x over 2 minus x is greater than or equal to 5. So a straightforward inequality. Lots of different methods. I'm going to use the critical values method. So I know that x cannot equal 2. Now I'm going to solve this equation to get the other critical point. Multiplying both sides by 2 minus x. Expanding. Collecting like terms. X is equal to 10 over 6, which is 5 over 3. All right, let's draw a number line. So we've got 2, and it cannot be equal to 2, and we have got 5/3, and it could be equal to 5/3 because I can see the equal sign there. All right, let's test some points. I always start with 0, which is down here. So substituting 0 into here. 0 over 2 minus 0 is greater than or equal to 5. 0 is greater than 5. No, it's not. Okay, now let's try something in here. So let's say 3. So x is equal to 3. This was x is equal to 0. Putting 3 in. 3 over 2 minus 3 is greater than or equal to 5. This is 3 over negative 1. So negative 3 is greater than or equal to 5. No, it's not. And finally, testing something in here. Let's see, that's 1.6. And let's try 1.8. Okay, so we've got 1.8 over 2 minus 1.8 is greater than or equal to 5. I'm just going to grab my calculator. See what that's worth. 1.8 over 2 take away 1.8 is 9. 9 is greater than or equal to 5. Yes, it is. So therefore my answer is going to be 5/3 less than or equal to x less than 2. Question 12a. A direction field is to be drawn for the differential equation as shown on the diagram on page 1 of the question 12 writing booklet. Clearly draw the correct slopes of the direction field at the points P, Q and R. It's actually a nice easy question. We're just going to substitute in. So let's start with P. Putting in x is negative 1 and y is 1. Negative 1 all squared plus 1 squared. What is this equal to? Negative 3 over 2, negative 1.5. So it's fairly steep and negative. Maybe something like that. Now let's do Q. X and y are both 1. So 1 take 2 over 1 plus 1 is equal to negative 1/2. So again negative but quite flat. Use a gradient of 1 as your measure. And now R, we've got 2 and 1, so 2 take 2, that's going to be 0, over 4 plus 1, yeah, is equal to 0, so completely flat. Here we go. Question 12b. A sports association manages 13 junior teams. It decides to check the age of all players Any team that has more than 3 players above the age limit will be penalised. A total of 41 players are found to be above the age limit. Will any team be penalised? Justify your answer. Now, in your reading time, you should have a look at this question and try and figure out what mathematics is required. It's obviously a probability or combinatorics type question, but hopefully in your reading time you figure out that it's actually pigeonhole principle. So what we need to do is divide that 41 by 13, and we get 3.15. So if this 41 players were spread evenly through the 13 teams, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, there would be 3 in each of the teams, etc., etc. And then if I do 3 times 13, that's 39. There are going to be 2 players left over, so this is remainder 2. And they will have to go into one of those teams. So by the pigeonhole principle, yes, a team will be penalised because at least one team must have at least 4 over age players. 12c. Find the equation of the tangent to the curve y equals x arc tan x at the point with coordinates 1, pi and 4, and give your answer in the form y equals mx plus c. So we'll start by differentiating. We have got a product rule here. So u is equal to x and v is equal to inverse tan of x. Differentiating, u dashed is 1, v dashed is equal to 1 over 1 plus x squared. And then forming that, y dashed will equal u times v dashed plus v times u dash, which is 1. Let's tidy that up. Okay, we want to figure out what m is going to be. So we need to substitute in x is equal to 1, because remember, this here is the gradient of all the tangents to the curve. So if I want to find the specific one, the gradient of a specific tangent, I need to say at x is equal to 1, y dashed, which of course is equal to m, the gradient of the line, is going to be, I'm just substituting the 1 in, 1 over 1 plus 1 plus inverse tan of 1. So what is that? That's a half plus inverse tan of 1, that's pi on 4. Okay, now we'll come over here and we're going to substitute in to y minus y1 equals m brackets x minus x1. So using this point and this gradient here. So y minus pi on 4 is equal to m, I'm going to put that in brackets, and then x minus 1. Now I'm not going to expand these brackets, well I will a little bit actually, because I need to get into this form here. So I've got y is equal to a half plus pi on 4 x minus, and now I'm just going to do this whole thing here times the negative 1, minus a half, I'm going to expand through those brackets, hopefully that's alright, and then taking this pi on 4 over the other side becomes plus pi on 4. The final answer, come up here, ran out of room, sorry, is equal to, here's m, and there's c. That's the answer. 12d. In a room with temperature 12 degrees, so that's our ambient temperature, coffee is poured into a cup. The temperature of the coffee when it is poured at time 0 is 92 degrees. The temperature capital T in degrees Celsius of the coffee T minutes after it's made can be modelled by using this differential equation. K is the constant of proportionality, T1 is a constant, it's actually the ambient temperature. So we know that T1 is going to be equal to 12. Now remember, this is Newton's law of cooling, which says that the rate of change of the temperature is proportional to the difference between the temperature of the object and the surrounding temperature, the ambient temperature. It takes 5 minutes for the coffee to cool to a temperature of 76 degrees. Use separation of variables and solve the differential equation to show that this is the solution. Okay, we've been given a method. We cannot differentiate this to get this. We have to integrate and we have to use separation of variables. So let's start with dt is equal to k bracket t take away 12. All right, I'm going to take this down here and this up and over there like this. We've got dt over t minus 12 is equal to the integral of k dt. So this is a log on the left hand side is equal to kt plus c. All right, let's raise both sides as powers of e. Now I'm going to split that right hand side, take the 12 over at the same time, e to the kt times e to the c, and I'm going to rename e to the c as a. Okay, we're ready to substitute in. What do we know? This guy. When t is equal to 0, capital T is 92. 92 is equal to 12 plus a e to the naught. A e to the naught is 1. And so a is equal to 92 take away 12, which is 80. Coming over here, we have got now t is equal to 12 plus 80 e to the kt. And we're going to substitute this in now. So capital T is 76, e to the 5k. So let's solve that equation. 76 take away 12 is 64, is equal to 80 e to the 5k. Divide both sides by 80. Take logs of both sides. 64 divided by 80 on my calculator is 0.8, that is 4/5, is equal to 5k. K is equal to 1/5 ln 4/5. Therefore, t is equal to 12 plus 80 e to the 1/5 ln 4/5 t. Part 2. The optimal drinking temperature for a hot beverage is 57 degrees. Find the value of t when the coffee reaches this temperature, giving your answer to the nearest minute. So this is what we had. Capital T is equal to 12 plus 80 e to the 1/5 ln 4/5 t. All right, we want to know when capital T is 57, so we've got an exponential equation to solve. All right, take the 12 over, that gives us 45. Divide both sides by 80. Take logs of both sides. What's 45 divided by 80 in the simplest form? It is 9 on 16. Equals 1/5 ln 4/5 t. Therefore, t is going to be equal to 5 ln 9 over 16 divided by ln 4/5, and I'm going to use my calculator. 5 times ln 9 divided 16, be careful your brackets there, over ln 4 divided by 5 is equal to 12.89. Now let's just have a look and see how they want this. This is it's in minutes, and give your answer to the nearest minute. Therefore, t is approximately equal to 13 minutes. Question 12e. The game consists of randomly selecting 4 balls from a bag. After each ball is selected, it is replaced in the bag. The bag contains 3 red and 7 green balls. For each red ball selected, 10 points are earned, and for each green ball selected, 5 points are deducted. For instance, if a player picks 3 red balls and 1 green ball, that's 25 points. What is the expected score in the game? All right, so I've got to think about the different possibilities here. Because we have replacement, we could get 4 reds in a row. We could get a combination of 3 reds and a green. We could get a combination of 2 reds and 2 greens, or 1 red and 3 greens, or 4 greens. Right, we need to work out the probability of each of those happening. So in this first case here, it is simply going to be, we've got 3 red and 7 green, so it's going to be 0.3 or 3/10 to the power of 4. Now with 3 reds and 1 green, there is going to be 4C3 ways to choose the order of the 3 reds when they appear, times 0.3 cubed times 0.7. 2 reds and 2 greens, 4C2, 0.3 squared times 0.7 squared, 1 red, which is 0.3, and 3 greens. And then finally, only one way to order the 4 greens, which would be 0.7 then to the power of 4. Now we need to work out the points total. So we've all been told this one. This is 3 red and 1 green, so that's here, 25. If we picked 4 reds, we would get 40 points. 2 reds and then 2 greens is 10 points. 1 red, 3 greens is -5, and 4 greens would be -20. And it's a matter of multiplying these together and then adding them up. Now I'm not going to bore you with that calculation. When you do that, you get your expected score is going to be -2. Question 12F. Use mathematical induction to prove 15 to the power of n plus 6 to the power of 2n plus 1 is divisible by 7 for all integers n greater than or equal to 0. So step 1, let's prove it true for n is equal to 0. Substituting in 15 to the power of 0 plus 6 to the power of 0 plus 1 is equal to 1 plus 6, which is 7, which is divisible by 7, therefore true for n is equal to 0. Step 2. Let's assume it's true for n equals k. So 15 to the k plus 6 to the 2k plus 1 is going to be equal to 7 multiplied by some integer m. Step 3. Prove true for n equals k plus 1. Right, starting with 15 to the k plus 1 plus 6 to the 2 brackets k plus 1 plus 1. Let's split this up. This is 15 times 15 to the k. And let's tidy that up. Sorry, that's a plus there. Plus 6 to the 2k plus 3. All right, now I'm going to use my assumption. I'm going to substitute in for 15k. So 15 lots of. Making this the subject here, I'm going to have 7m minus 6 to the 2k plus 1 plus 6 to the 2k plus 3. And expanding, now I'm not going to work this product out because I want to leave that 7 visible. Minus 15 times 6 to the 2k plus 1 plus, I'm going to turn this into 2k plus 1 plus 2 equals 15 times 7m minus 15 times 6 to the 2k plus 1 plus 6 to the 2k plus 1 times 6 squared, which is 36, equals 15 times 7m. What have we got here? 36, take away 15, that's 21. And we can see a common factor there of 7. Therefore, divisible by 7. Therefore, true for n equals k plus 1. Therefore, by the principle of mathematical induction, true for all n. Okay, that's it. In our next video, we're going to look at questions 13 and 14.